Good morning, everyone. So today I'm going to be presenting this little application that we built internally at Abstract that is using our latest IBC technology, and it's called IBC Mail. So you can send your Interchain nudes. The team. So I am Robin at the Cyber Howard on Twitter. I'm here with the IBC wizard Nicholas and with my co-founder Adair. And we're here to preach Abstract. So what are we going to talk about today? We're going to talk about AwesomWasm IBC development, CW Orchestrator, Abstract IBC, the mail app that we built, and then I'm going to show you some of the code in my editor. And on the right side, you see a little bit of a graph of our protocol. So das Problem. What's the problem here? A lot of people try to work with IBC, but it's actually really hard, especially in AwesomWasm. There isn't a lot of documentation. There's a lot of technicalities. So specifically, all the things you have to think about, they're not all listed here, but the most important ones are, if you do AwesomWasm IBC, you need to think about the structure of your IBC packet, like what kind of data are you actually going to be sending over to the other chain, and then like when you get a response, how do you match that with your initial packet, etc., etc. So there's a lot of like protocol design kind of you need to do when you design the data format for that. Then running a relayer is also pretty hard, especially when you're testing. Like it can get very troublesome. Channel ownership, so who is actually going to be owning this IBC channel? Are you going to own the contracts? Is that okay for your application or for the users of your application? Authentication, so when you receive an IBC message, how do you ensure that it actually came from somewhere you trust? The ineffective tooling, so there isn't really that much tooling, AwesomWasm focused tooling, to really do development in the IBC space. Manual integrations. With this, I mean like the different standards, like token transfers, the IBC hooks has been a complete kind of mess to use in AwesomWasm. The slow feedback, because the testing isn't great. You have to spin up chains. You have to test your IBC with like relayers. It takes a lot of time to set those up and also to run the tests themselves because you have to wait for block production. And there are a few experts. Not a lot of people have actually tried to do this. So maybe put your hands up if you have used AwesomWasm and IBC and like wrote actual IBC code. Okay, yeah, but this is like a AwesomWasm hackathon, so there are a few hands, but yeah. It's rough. It's rough. I think you get the point. So to address at least some of these problems, we added a lot of IBC tooling to CW Orchestrator. So if you don't know what it is, what the fuck are you doing? CW Orchestrator handles everything AwesomWasm related, and we also have this new environment that we actually just made public. So we had this repository, CW Orchestrator Interchain, that was private, that we've been using internally a lot to test all of our IBC code, and we now made it public so you can actually go and use it. And one of the biggest features in there is this CW multitest that has IBC. So you can spin up different mock chains and then run your test natively, so you get very fast feedback on your test. And we also integrated with existing platforms and tooling, so you can connect to testnets, you can connect to mainnets, you can do your deployments there, set up your IBC channels, etc., etc. And also Starship, which spins up local devnets and relayers and stuff. So the tooling is there. Let's start building, right? Oh, okay, that's sad. This was actually GIF. Well, not so fast. Not so fast. We can't start. So let me tell you a little bit more about how I personally experienced onboarding to IBC. I learned IBC at Hackathon 2022, which was like the first real AwesomWasm hackathon, from what I understand. And I had to learn about channels, spectral life cycles. I spent hours debugging the Hermes relayer. Turns out there were some bugs that prevented it from relaying AwesomWasm packets sometimes. There were no callbacks. There still aren't callbacks for ICS-20 packets. There were no IBC hooks on Osmosis, which is a chain that we were trying to use. So we had to do this hacky way of like sending tokens, checking that they're there, and then doing the action and blah, blah, blah. It was very, very hard, and I wouldn't recommend it. So, but we still won the hackathon, which is amazing. But we also learned a lot, and we set out to create a better experience for other developers. So that is where I'm gonna kind of leave that introduction and start talking about our actual code. So this is Abstract SDK IBC Mail. This is public repository. You can clone it and kind of look around, but I'm gonna show it in the next few minutes. So let me check it. Okay. So first, a little introduction to what Abstract actually is. So Abstract is a smart contract framework that is centered around Abstract accounts. And Abstract accounts are smart contract wallets that are modular. So you can create an Abstract account and then install modules on top of it. And the modules have permissions to execute actions on the account. So this way you can create composable applications, modular and composable applications. It's very easily programmable, which is what I'll show you later in the code. You can also do a lot of version management on chain, so you can upgrade certain parts of your code and certain parts of your application and have that be asserted on chain, that those versions actually match. And then it's also IBC enabled, which is the topic of today. So the first kind of IBC feature that we implemented are interchain abstract accounts. And interchain abstract accounts allow any account owner to create interchain abstract accounts on other chains. And the way that this works is the owner just calls a local account saying, hey, I want to register an account on Terra. And then the account will route that through our infrastructure. It will create an interchain abstract account, which is essentially just the exact same contracts as a local account, but it's owned by what we call the IBC host, which is responsible for transporting the packets between the chains. And then this remote account is controlled by by the owner account, and you can actually create multiple hops. So an interchain abstract account can create another interchain abstract account, and that another one. So it's kind of like how you can send ICS-20 tokens through different routes. You can create interchain abstract accounts through different routes. And the main use case here is, first of all, programmability. So everything is in Rust, and you can very easily script this and execute, etc. And you can also build multi-chain applications with this, like simple multi-chain applications. What about like the more out there multi-chain applications? So that is why we created interchain module communication, which is essentially creating a communication layer between modules that are installed on accounts. And the reason why you would do this is going to become clear when I show you the code. But essentially it allows any application to send a message to an application on another chain, and then the receiving application can verify that that the message it receives comes from a specific application. So you can say, if I'm like a mail server, for example, I can say, I only want to receive other messages from mail servers, right? And then I can actually rely on that and handle my logic that way. So when I send a message with this technology, I need to provide a target chain. So where I want to send a message, a target module, so which like kind of application I want to target, or which essentially resolves into an address on chain, the smart contract address, the message that I want to call, as well as a callback. So if the message fails or if it succeeds, I got a callback with the result, and I can use that to progress my state machine. So let's try and build on this. This messaging protocol is supposed to allow two accounts to send messages to each other. And either they can send it locally. So if my co-founder has an account on Kujira, then I want to be able to just send him a message and say, hey, you owe me $10, motherfucker. And if it's over IBC, then I need my infrastructure to just handle it. I want to send it somewhere, and then it needs to get to Adair. And this can use either account IDs and the chain, or a namespace, which is a concept native to Abstract. It's used to publish modules under. You can learn more in our documentation about this. So we first start with a client. The client can send and receive messages. So this is the contract that a user will be interacting with. And it also stores messages that it receives locally. And these are the two endpoints that it has. So send message, you provide a message and it sends it. And receive message is when it receives it from a server. So then for local routing, what would happen is you call the IBC client, you tell it, hey, I want to route this message to Adair. That sends it to the IBC mail server. The server verifies that it receives a message from a valid client and then forwards that message to Adair's client. And how would that work over cross-chain? So in this case, we use the servers to communicate over IBC with each other. And when we provide our message to the client, this message gets sent to the server, and then we provided a route with the message. So the server knows, hey, the user that is trying to reach isn't actually on this chain. It's on Kujira and I'm on Neutron. So I need to IBC this message to the server that is on Kujira. And then the server that receives it there will be, okay, this is actually the chain that the message is supposed to go to, is going to Adair, okay, I'll send it to his client. And then he receives a message. So now I'm gonna get into the code a little bit and show you around. This is the GitHub repo URL. So abstract SDK IBC mail. And this is the repo. So we have a package here with some definitions. So this is the client. I don't know if this is big enough. Yeah. Sweet. So here's some CW orchestrator macros that are very useful for the tests. But here are the two messages that I showed earlier. So we have this message when we want to send a message, and then a route an optional route that we can provide. Once we provide this, it goes to our client, and this I'll explain a little bit of this abstract syntax here. So previously in my presentation, I was talking about modules. We actually have two kinds of modules. We have app modules and adapter modules. App modules are account-specific modules. So when you want to interact with an application, an app module, you need to install it on your account and you get your own instance of it. And you control the smart contract, you control the version of the contract, you control anything that it can do. So it's fully non-custodial. And in this case, we're defining an app, we're giving it an ID, as well as a version, and then we're giving it the handlers. And the handlers are what's gonna be called when someone executes on a contract. So you have an execute handler, query, migrate. This should be familiar to you. And then you can add dependencies. So here we have a mail server dependency, which means that we want to ensure that the mail server is actually valid on the account when this contract is instantiated. And that ensures that the API calls that the client is doing to the server, that those will be formatted correctly. Because if you have a mismatch in version there, then it could be that the message that you're calling is not correct. just previously, hello, hello. The app that we just previously constructed. And this app implements a bunch of traits that we can use later on. So for this send message example, we can go into this function, and then we're just creating a hash to store it. We're creating our IBC mail message. We're adding the sender, etc., saving it to storage, and then this is where the beautiful part of abstract comes in. We have our app object, and there's an API, which is like a trait that our server implementation exports, and we can construct this API with our app objects, and then this mail server implements functions to actually call it. So we can say server.processMessage, which will take in a message to send and a route, and then return a Cosmos message that we can just execute. So this way, our client can talk to our server and execute the messages and route it. Yeah, for the receive message, it's kind of similar. So then on the server side, when we have a similar contract, but in this case, it's an adapter. And the adapter is a single instance that everyone else uses. It's non-migratable, but everyone else can reference it. So we do the same. It's the same syntax. We give it a unique identification and a version, and then in this case we only have an execute handler. So that's when it's called locally, and we also have a module IBC handler, which is when it receives a message over IBC. And I think it's the second one that's the most interesting one. So when it receives a message from over IBC, then we get the server adapter, which is similar to our app previously. And we also get this module IBC message. And this module IBC message defines which chain is calling in to my contract. So the source of the IBC message, and then also the module information about which module was actually calling me. So in this case, the namespace, the name and the version are going to be similar to my server, right? It's the same IBC mail server ID as what I defined in my contract up here. So I'm saying I'm on a different chain, but when I get a message, I want that message to come from another instance of myself, basically. So it's kind of peer-to-peer in that way. And then if it's not, then we throw an error. We deserialize our IBC or server IBC message, and then we figure out the route. If it's local, then we just route it to the local client, and if it's another hop further, then we do another IBC hop. So that is that implementation, and I can now show you a little bit of a demo. I think it's this file. So this is using CW Orchestrator Interchain, and this is a test binary. We have a runtime here that we define. We pass it onto this daemon interchain environment where we can give all the chains that we would like to interact with. In this case, it's Pion and Harpoon 4, which are the testnets for Kujira and Neutron. We get the individual chains from our interchain environment, so we can interact with them directly. We have this abstract client, which allows you to interact with the abstract infrastructure very easily by just providing your environment. So in this case, the source and destination, which are Pion and Kujira. And then we have an account builder. So this lets you create an account based on a namespace. So if the namespace is already created or claimed, it will just retrieve the account. So we can run this multiple times. And then we can get our application from it. We already installed our application previously, so we're just retrieving the client from our account. and then we get this application with the client interface. We do the same for the destination account, and then we create this mail message. And this mail message is a message that we want to send over our mail. And I think I need to change this because it might conflict with the hash that was previously stored there. It's like 7 or whatever, doesn't matter. And then we take our client, which is the client application, and we call the send message, which is this execute variant that I showed at the start. And this function is generated with Orchestrator. So that's why I mentioned the macros that were on that message. We provide the message, we provide the route, and we get a custom transaction response. And we call interchain wait IBC, which will track the execution of this packet over IBC. So I'm now gonna try and run this and see if it works. Cool, so it's executing. Oh, that's a packet. So we have some packet information, and now it's waiting for the packet to be relayed. And oh, received on Harpoon 4. Okay, and we got the acknowledgement. So, yeah, we just sent an email over the interchain. Cool, so for the developers that are here, we have 2 bounties. The first is to build an interchain app using any of our IBC infrastructure. And then the other one is to integrate a new service. We currently, for example, don't support regular ICAs in the framework. So one of the bounties you could do is to integrate that into our framework, so it's made available to other developers to use. So thanks for your time.
Yes, hello. I was wondering, thank you, Robin, and if there's any questions and if you would like us to dive a little bit deeper into the code, because there's some very unique abstract features here that make your lives way easier, and we may have skimmed over them in this presentation, and we still have 20 minutes. So yeah, any questions? Okay, so one, I think that we should go and look at the client implementation and look at this API that where we call the mail server. So if we close this and we close here, we are in client handlers execute. So these are a normal execute handler in the send message function. So the first few lines are just creating that message to send. We store it in our sent messages, but right here, this is where we access the mail server.
I showed that.
Yes, but you didn't click into it. So this mail server, the server interface is a trait implemented on our app object or abstract, as he mentioned earlier. And this hides a lot of the complexity of interacting with other modules that are installed on your abstract account. So in the diagram that he showed earlier, when you have the mail client installed, the mail client actually depends on the mail server, which is also a module that's installed on that account. And so your account is aware of which modules it can interact with. So here you can see that when you call process message, it actually requests that server to process that message, and it automatically routes it without you even having to know what the address of that module is or how to get that module there. So the APIs for these make it really, really easy. Additionally, we have these for a lot of the common actions that you may do in AwesomWasm, like bank sends and transfers and just interacting with the account, sending funds, what else? Interacting with DEXs or lending markets. So if you're doing the Kujira track with the lending market, we have a really easy API there. Same with the Astroport and Mars, DEX and lending market.
Yeah, and a lot of these APIs can be found in the abstract SDK crate and the documentation below here. So you have all these traits that allow you to either retrieve information or do things like transfer assets. So for example, this transfer interface allows you to create a bank object. And if I can click into the bank object somewhere. Zoom in, yeah.
Hit function and then command plus. Or, well, because the change keyboard and then command plus. Or at least that's
How do you do it?
Yes, but it's we use a different keyboard layout.
Zoom here. Plus. Amazing. Yeah, so then you can get this bank object, and then with the bank you can get balances, so you can do queries. You can also transfer funds. When you transfer funds, it will transfer it from the account that this application is installed on, not from the address of that application. If you want to like deposit into your account from your current application, that's available. If you want to withdraw from your account, that's available. So yeah, all these helpers are available.
Yes. Okay. And so, we showed you these APIs, but we did not show you how easy it is to interact with the IBC interfaces. We showed you the recipient message, though let's also look at when we send the message to the module over IBC. Nicolas and Robin spent a lot of time making this as easy as possible and replicated the kind of how this process is for sub-messages. So it should be very familiar to you as an AwesomWasm dev. So yeah, you can see here, we tell the, we've abstracted this away a little bit more recently, that you can see that you generate a message to the IBC or to the server. So this is just like the same message that you send traditionally. You can tell it to route the message, you give it a callback, and then you execute that on the IBC client. And then your contract handles it just like it would any other reply. So you see here, this is not what receives module IBC. Oh, it is. It is. So yeah, and this is the IBC handler that he showed earlier.
So the extremely nice thing here as well is that you don't have to spin up any relayers if we have a connection there. So we use Polytone as our messaging protocol, like IBC messaging. So if there's a Polytone channel between one chain and another, then you can just use this code, deploy it to Abstract, and it will use that Polytone channel, and you don't have to worry about any of the DevOps that is that's required there.